Today we're going to introduce the exponential function. The logarithm function was defined earlier. The natural logarithm function was y equal ln x. The exponential function is the inverse of the log function, and the log function has an inverse. So if y equals ln x, that means x equals exponential of y, or e to the power y. This is the notation for the exponential function, e to the power y. So for example, if 1 is equal to ln e, that means e to the power 1 is equal to e. And if 0 is equal to ln of 1, that means e to the 0 is 1. So if y is the log of x, that means x is the exponential of y. Okay, x is the exponential of y. The graph of the logarithm function looks like this. The graph of the exponential function looks like this. Logarithm is like this, and then the exponential function is like this. For example, the log of e is 1. But then the exponential of 1 is equal to e. So the graph goes up to e here. We've heard of exponential growth. When something grows exponentially, that means it grows fast and it becomes large. It's true as long as the exponential is either e or a number that is greater than 1. Some properties of the exponential function. The products of two exponentials, e to the x times e to the y, is equal to e to the power x plus y. For example, e squared times e cubed will be e to the power 5. The quotient is e to the x minus e to the y. So e to the power 10 divided by e to the power 3 is the same as e to the power 7. E to the x to the power y is the same as e to the power xy. So for example, e cubed to the power 4 is e to the power 12. E to the power 0 is always equal to 1, and e to the power 1 is e. There exist other exponential functions with different numbers. Okay, some people may know a to the power x to be a times a times a times etc. times a x times. But what if x is not a whole number? Then what? Well, think of a to the x as the inverse of the log of x in base a. Likewise, the function when a is 10 to the power x is the inverse of log x, of the function log x. And here are some examples. ln of e to the power 4. We can do this in a number of ways. We could bring the 4 to the front, so it'll be 4 ln e. 4 ln e is 4 times 1 because ln e is 1, and that's equal to 4. Or we could simply say ln and e are inverse functions, so they cancel each other. So therefore, that leaves us with 4. The answer is 4. ln of square root of e. Square root of e is e to the power half. Same thing. ln will cancel the e, and that leaves you with a half. And then if you have ln of e to the power 99, that's just 99. Likewise, log in any base of that base, okay, is equal to 1. Why? Because log of a in base a is ln a over ln a, which will cancel, and that leaves you with 1. So log of 5 in base 5 is 1. But log 5 squared in base 5, log of 5 to the power will cancel, because 5 to the x and log in base 5 are inverse functions, they cancel. So that leaves you with 2. And here you have log 4 to the power 10 in base 10, no need to do anything. They cancel, that leaves you with 10. Log of square root of 2 to the power 88 in base square root of 2, the log in base square root of 2 and square root of 2 to the power will cancel, so that leaves us with 88. And the answer for this one is 88. And that's because those functions are inverse functions.